Have you ever wondered why the sky is blue, but space is black? Or why you can sometimes see the dark part of a crescent moon? What if I told you that right now, at this very moment, thousands of particles from outer space are passing through your body? The universe doesn't just exist in some distant realm through a telescope.
It is all around us.
It's here all around you, affecting everything you do, everything you see, and even your own weight, which changes throughout the day because of the moon.
Hey, guess what? People are bigger now. Build bigger doorways.
I'm about to read 14 incredible space phenomena that you experience every single day but probably never understood. And number 16? It explains why 1% of your old TV static actually came from the Big Bang itself. Stay until the end, and I guarantee you'll never look at the world the same way again. Let's begin. Imagine standing on the moon during daytime. Look up, and you'd see a black sky with stars, even with the sun shining. So why is Earth's sky blue? It's not actually the color of our atmosphere. When sunlight travels through space, it contains all colors. But when it hits our atmosphere, air molecules scatter the blue light in all directions while letting other colors pass straight through. This is called Rayleigh scattering. Without our atmosphere, our daytime sky would be as black as night with stars visible all day. And that gorgeous red sunset? It's the same effect, but when sunlight has to travel through more atmosphere at sunset, the blue light gets scattered away completely, leaving only the red and orange wavelengths to reach your eyes. Next time you look up at a clear blue sky, remember, you're seeing an optical illusion created by our atmosphere, not the true color of space. Here's something incredible: about 10,000 subatomic particles from space are passing through your body every minute. Right now, as I'm speaking, as you're watching, these particles, called muons, are created when cosmic rays from distant stars and galaxies crash into our atmosphere. Think of them as tiny messengers from outer space. The wild part? You can actually see these cosmic visitors with a homemade cloud chamber using just rubbing alcohol and dry ice. Those tiny streaks are particles that have traveled across the cosmos and through your body. Despite their abundance, these particles are completely harmless to humans. We've evolved alongside them for millions of years.
Wow.
Every compass on Earth is slightly lying to you. When your compass points north, it's not pointing to the geographic North Pole, it's pointing to the magnetic North Pole, which is constantly on the move. The magnetic North Pole is currently racing towards Siberia at about 25 miles per year, and it's accelerating. This movement is why military and aviation maps need regular updates. If you used a 50-year-old compass without adjustment, you could end up miles from your intended destination. Earth's magnetic field is generated by our planet's molten core, creating a giant, ever-shifting magnet that protects us from harmful solar radiation. Here's something mind-blowing about every sunset you've ever watched. When you see the sun touching the horizon, it's already completely below it. Light bends as it passes through our atmosphere in a process called refraction. This atmospheric bending lifts the sun's image by about its own diameter, creating a beautiful cosmic illusion. The practical effect? You get about 5 extra minutes of daylight every single day. Those gorgeous sunset photos you've taken? They're capturing something that's not actually there. The sun has already set.
Hey, okay. Man, what a badass.
That ordinary glass of water on your table? It's demonstrating the same physics that Einstein used to prove his theory of relativity and that astronomers use to detect distant galaxies. When light passes from air into water, it bends, changing direction. In space, massive objects like galaxy clusters bend light from distant stars in exactly the same way, creating what astronomers call gravitational lensing. This effect allows us to see galaxies that would otherwise be hidden from view. Einstein predicted this phenomenon in 1915, and your kitchen glass demonstrates it every day.
Amazing!
Have you ever spotted a bright flash in the night sky that appears and vanishes too quickly to be a shooting star? Those aren't celestial phenomena or UFOs, they're sunlight reflecting off satellites. There are over 6,000 satellites orbiting Earth right now, though only about 40% are still operational. When their solar panels or metal surfaces catch the sun just right, they create a sudden flare of light visible from the ground. The Iridium communications satellites were once famous for creating the brightest flares, sometimes visible even in daylight. Next time you spot one of these flashes, you're witnessing human technology interacting with sunlight nearly 500 miles above Earth.
Satellite above!
Depending on where you live, some stars in your night sky never rise or set, they just circle endlessly around a fixed point. These are called circumpolar stars. This phenomenon happens because Earth rotates on a tilted axis. If you're in the northern hemisphere, stars near the North Star, Polaris, never dip below the horizon. Instead, they appear to circle around Polaris throughout the night. Those beautiful circular star trails in night photography? That's not the stars moving, it's Earth rotating beneath them. The closer you are to the poles, the more stars become circumpolar. At the North Pole itself, all visible stars would be circumpolar, endlessly circling overhead without ever setting.
What?
We all know the moon causes ocean tides, but did you know it's actually tugging on everything on Earth, including you? The moon's gravity creates two bulges, one on the side facing the moon, and surprisingly, another on the opposite side of Earth. This is why most coastal areas experience two high tides and two low tides each day. But it doesn't stop with water. Earth's solid ground rises and falls about 12 inches with these tides, we just don't notice it. And these tidal forces are gradually slowing Earth's rotation, making our days longer by about 1.7 milliseconds per century. In 100 million years, a day on Earth will be about 25 hours long, all because of the moon's pull.
I won't believe it. I can't believe it.
Try this right now. Hold your thumb up at arm's length, close one eye, then switch to the other eye. Your thumb appears to jump against the background. This simple trick demonstrates parallax, the same effect astronomers use to measure the distance to stars. Your brain naturally uses parallax from your two eyes to judge distance. It's partly why depth perception is harder with one eye closed. When astronomers take measurements of a star from opposite sides of Earth's orbit, the star appears to shift position against more distant background stars. The first successful stellar parallax measurement in 1838 finally proved conclusively that Earth orbits the Sun. Your simple thumb trick demonstrates cosmic measurement techniques used to map our galaxy.
Charles, thumbs up.
Have you noticed how during a crescent moon, you can often faintly see the entire moon disk? The bright crescent is lit directly by the sun, but what's illuminating the rest? It's called Earthshine, sunlight that bounces off Earth, hits the moon, and returns to our eyes. You're actually seeing sunlight that made a round trip, sun to Earth to moon to your eyes. Earth reflects about 30% of the sunlight that hits it, compared to the moon's 12%, making our planet quite bright from space. When astronauts look back at Earth, they see a brilliant blue marble shining in the darkness. Earthshine is most visible during crescent moons near sunset or sunrise, when the crescent is thin and the rest of the moon isn't overwhelmed by direct sunlight.
This is amazing.
Amazing.
You've probably heard that toilets flush in opposite directions in the northern and southern hemispheres due to Earth's rotation. Is it true? Not exactly. For small bodies of water like toilets and sinks, the Coriolis effect, Earth's rotation affecting fluid movement, is far too weak to determine which way water drains. The shape of the basin and the direction water enters have much more influence. However, for large weather systems, the Coriolis effect is dramatic. It's why hurricanes rotate counterclockwise in the northern hemisphere and clockwise in the south. So while your toilet isn't demonstrating Earth's rotation, every major storm on our planet certainly is. During certain moon phases, especially the first and third quarters, the moon appears dramatically three-dimensional, almost like a sphere hanging in space. This effect occurs along the terminator line, the boundary between the lit and unlit portions. This line highlights lunar mountains and craters through dramatic shadows, revealing the moon's topography. When the sun hits the lunar surface at a low angle, even modest mountains cast long, dramatic shadows. This terminator line moves about 10 miles per hour across the lunar surface as the moon orbits Earth. The 3D effect is most noticeable when the terminator cuts across regions with dramatic terrain, especially the heavily cratered highlands. In very dark locations after sunset in spring or before sunrise in autumn, you might notice a faint, triangular glow extending out from the horizon. This isn't light pollution, it's the zodiacal light, a phenomenon caused by sunlight reflecting off cosmic dust in our solar system. This dust comes from asteroid collisions and comet tails, forming a thin disk in the plane of our solar system. When the sun is just below the horizon, its light illuminates this dust, creating the ethereal glow. Ancient civilizations incorporated this mysterious light into their mythology and astronomy. It's one of the oldest astronomical phenomena observed by humans, yet many people today have never seen it due to light pollution.
Love that.
Look up at the night sky and you'll notice stars twinkle, while planets shine with a steady light. Why the difference? Twinkling, scientifically called stellar scintillation, is caused by Earth's turbulent atmosphere distorting starlight. As this light passes through pockets of air with different temperatures and densities, it gets refracted slightly, making stars appear to change position, brightness, and even color. Planets don't twinkle as much because they appear as tiny disks rather than points of light, averaging out the atmospheric distortion. Space telescopes, which operate above our atmosphere, see both stars and planets as perfectly steady points of light.